A good day, gentlemen. I again hope all to be doing okay and to be pushing as well. So remember that consistency is best. So now, gents, I want us to continue with the hyperbola. This time around, I want us to focus on the equations of the axis of symmetry. So now remember that the axis of symmetry is a straight line that cuts a curve in half. So now the hyperbola itself has two axes of symmetries. So now the hyperbola has the axis of symmetry with a positive gradient as well as one with a negative gradient. So now all these are axes of symmetry stem from one point. So now this is a point brought on by the asymptotes. So now remember that you would have your horizontal asymptote, which would be y equals q, and you would also have your vertical asymptote, which would be x equals minus p. So now where these points meet, so that would be that point over there. So that was actually in green to begin with. So I'll just make use of the color green. So that point over there, which we can refer to as point A, is the point where the lines of symmetry pass. So we can draw out a line of symmetry with a positive gradient. So I'll just maybe draw it with a the green color over there. So now that would be the axis of symmetry with a positive gradient. And you would also have an axis of symmetry. So I'll just maybe, let me use this color here. So you can also have an axis of symmetry with a negative gradient. So I'll just maybe have that put like that. So now the axis of symmetry with a positive gradient would have the general equation. So that would be the general linear equation. Y equals x plus c. So the gradient would be positive 1, and the c would just be the y-intercept. You would then also have the axis of symmetry with the negative gradient. Now this would be y equals negative x plus c. So now to solve for c in each case, you would need to make use of the point negative p is to q. So that would be this point of intersection over there. So now remember that these axes of symmetry, or the equations or the lines themselves, cut the function in half, which is essentially what an axis of symmetry does. So now to find the c's, you would need to make use of the point negative p is to q, as we already mentioned. So now for you to do so, you would just need to substitute in. So that would be q is to negative p plus c, and you would then just end up with a q plus p. But then this in itself will depend on the value of p and the q as well. So hence, I've also just prepared a question for us to look at. So now in the question, we've been given the equation y equals 1 divided by x plus 2 minus 3. And we are asked to determine the equations of the axis of symmetry. So now if we were to maybe write out these equations, I'm going to just draw out the equation. So remember that they stem out from this point over here, which is the point of intersection of the asymptotes. So I can just maybe have it like that. So that would be 1 over there going through. And then you would also have another one going through that way. So that would be that equation over there, or rather that line over there. So now this line over here, your equations of the axis of symmetry would have a positive gradient. This one over here would have a negative gradient. So that in itself is standard. This is what you start off with. To find C, you would then need to make use of the point. So remember that this point is brought on by the asymptotes themselves. So that would be these asymptotes over here. So that's the -2 for the x and the -3 for the y. So these over there. So now to find the c, we will use the point -3 is to -2. Actually, this in itself, I seem to have made a small mistake there. So this should actually be a -2 is to -3, since the x would be -2 and the y would be -3. So now this in itself would be -3 equals -2 plus c, and c would equal -1. Therefore, y would equal x minus 1. For this equation over there, we would have a -3 equals -2 plus c, and we would have a -3 equals 2 plus c, and therefore c would equal -5, making the equation for the axis of symmetry to equal -x minus 5. So now this would be the axis of symmetry, or the equation of the axis of symmetry with a positive gradient. And this over here would be the axis of symmetry with a negative gradient. So now, gents, that's what I wanted to share with you guys today. Please do have a look at the vid so that you may be able to attempt the questions that do follow. A very good day to all.